All right, chapter 6, polynomials. This is the first section, so there's going to be a lot of vocab, just a lot of identifying and kind of describing what's going on. A little bit of graphing here, but not a lot of math per se. So let's jump into this. So first of all, a monomial. A monomial, mono means one. So a monomial is a number or a product. Remember, that means multiply. Multiply of numbers and variables with whole number exponents. So here's some examples of a monomial. It could just be a number. It could be a number 7. It could be, x to the third power. That's a monomial. It could be numbers and letters. It could be negative 5 x squared y. All right. So that is a product of numbers and variables with whole number exponents. So any of those things are monomials. I kind of think of it as basically like a chunk. All right. So it's just one chunk or term in a sequence there. So the next one says a polynomial. Poly means many. All right. So a polynomial is a monomial or a sum or difference of them. So it's like a bunch of terms linked together with pluses and minuses. And every monomial is a term. So for instance, last chapter we were factoring things like, x squared minus 5x. I don't know, let's just say minus 14. All right, so that right there, this is a polynomial, and it's actually got 3 terms. So we have the x squared piece, we have the minus 5x piece, and then we have the minus 14 piece. So this one would have 3 terms, and it's called a trinomial because there's 3 pieces. So this would be a trinomial. If we were to factor that, we could have factored that thing out. 2 numbers times together to make negative 14, add to make negative 5. So something like that. Well, those are called binomials. All right. So this would be a binomial times another binomial. And it ends up being a trinomial at the end. So polynomials have no variables in the denominators or exponents, no roots, so no square roots, no absolute values, and your exponents have to be whole numbers. So here's a couple examples. So one polynomial might be, 1/2 x to the 4th power plus 2x cubed plus, 4x squared minus 5x plus 1. So notice I put I started at the power of 4 and I worked my way down 4, 3, 2, 1, 0, all the way down. So that would be what's called standard form. I'll talk about that here in a minute. But you don't have to be. You could just be, 5x to the third, take away 2x. That's a polynomial with 2 terms. Now, here are some things that are not polynomials. All right, not polynomials would be something like 7 over x. That's not a polynomial when you have an x in the denominator. Or if you do like 4x to the 2/3 power. That 2/3 is a problem there. All right, that's a fraction exponent, not allowed. You can't do like the square root of 4x to the 3rd. That's not allowed because the square root's a problem. Can't have absolute value. So this is not a polynomial. So the things that are the problems here are the absolute value brackets, the square root bracket, the fraction exponent, and then the variable in the denominator. All of those things kind of wipe you out, so you're not a polynomial. All right, now we're going to start talking about the degrees of the polynomial. So the degree of a polynomial, another vocab word here, the degree of a polynomial is the sum, that means you're going to add, the sum of the exponents of all the variables. All right, so the directions say identify the degree of each monomial. So in the first one, there's only one exponent, so the degree is 4. The next one, there's no variable there. So we say it has degree 0. You could honestly think of this as 16x to the 0 power, because remember, x to the 0 power is really just 1, and 16 times 1 would just be 16. So when there's no variable, it's to the 0 power. Well, this one I have a 2 here and a 1 there. So when I add 2 plus 1, that's degree 3. And this one over here would be 3, 4, and 1, which is a degree of 8. So when you want to find the degree of a monomial, You're just going to add the exponents of the variables. Now, a little bit different, when you want to find the degree of the polynomial, the degree of the whole thing, it's given by the term with the greatest, the biggest degree, all right? And the one I wrote up above and the one down below is in standard form. Standard form just means that you're going to go decreasing powers. So notice that we have x to the third, x squared, x to the first, and then this end one would kind of be considered x to the 0. So when you decrease the powers like that, you're in standard form. And when you want to find the degree of the whole thing, it's right here. It's just the biggest term. He kind of is what you name it by. And then the number in front of that biggest term is referred to as the leading coefficient. And that's going to come into play when we're graphing here. So those are kind of how we find the degree for the entire polynomial. So I think we have some examples here. Actually, we have a little classification chart. So we can name them or classify them by the number of terms. We already talked about 2 terms as a binomial, 3 terms as a trinomial. But going through these, numbers by themselves are just constants. Anything where the x has degree 1, it's a linear, it's lines. We spent all of the last chapter doing quadratics, which had powers of 2. If you have the highest power is a 3, it's a cubic. Highest power is a 4, it's a quartic. And highest power of 5, it's a quintic. All right? Not the end of the world if you don't memorize those right now. Cubic, you definitely want to know. The other one's a little bit less, but quadratic, cubic, linear, constant, those are some terms that we definitely got to have in our arsenal. So let's go down here. It says rewrite each polynomial in standard form. All right, so I need to rewrite in standard form. I'm just going to call that SF. And then we need to identify the leading coefficient, the degree, the number of terms, and we need to name it. All right, well, standard form. So I have 3 terms here, and we need to put these in order from biggest power to littlest power. So I'm going to have a negative 2x squared, a positive 4x, and a positive 2. So there's my standard form piece. Now we want to identify the lead coefficient. I'll just call it LC. The leading coefficient is negative 2. It's that number in front of the highest power. The degree, well, this thing is degree 2 because the biggest power there is a 2. So the polynomial is degree 2. The number of terms, well, this is a trinomial. So there's 3 terms. 1, 2, 3 terms there. And then we name it, since the highest power is 2, the degree, that kind of tells me that this is called a quadratic. So I answered I did all 5 things, standard form, and then the other 4 questions. So let's do number 6. Standard form, it looks like x to the third is the big dog. The negative 18x squared is next, the positive 2x, and then the negative 5. So leading coefficient is 1 because there's kind of an understood 1 there. The degree of this thing is degree 3, which I might as well use that to name it. If your highest power is a degree 3, you are a cubic. And what else do we have? We have the number of terms. Well, this one has 4 terms. 4 chunks here. We have 1, we have 2, we have 3, and we have 4 terms. All right. As far as the SAT goes, most of what you're going to do is something similar to 7 and 8, where you're either going to add or subtract some polynomials. We did a lot of multiplying quadratics earlier, but we're not going to spend a lot of time right now doing multiplying. That'll come up later. But let's just add or subtract. So when you add, basically outside these parentheses, you can just pretend there's a 1 there. And when you distribute that 1, it really just kind of wipes out the parentheses. So when it's addition, you can pretty much ignore the parentheses if there are no numbers on the outside. So I'm going to kind of drop the parentheses by distributing by 1, which doesn't do anything. Now I need to gather up some like terms. So the biggest term I see is this x to the third. So you're going to start me out. So you're gone. now I have a couple x squareds. I have an x squared and an x squared. So negative 36, positive 6, that's going to be a negative 30 x squared. So now you two are gone. Then we have the x terms, which is only one of them. And then we have some constants. Negative 11, negative 5, negative 16. So I did write my answer in standard form, going from big to small powers. So that would be the sum of those two added together. Now, subtraction, you got to be very, very careful. Okay? I'm going to put a big old eyeball here. I'm going to say, look out. Because whenever there's subtraction, you're going to have to distribute this negative 1, which is going to change some signs. So be very careful here. Front parentheses, a positive 1. So that really doesn't do anything. So I'm going to have 5x cubed. And I'm going to leave myself decent little space here. I kind of do that on purpose, just so I can kind of see things a little better. Now, when I distribute that negative 1, I'm going to have negative 15x squared, negative 3x, positive 2. Be very careful that you change all the signs in the second parentheses. Now I got to gather up some like terms. So there's only one x to the third term. X squareds, I have 6 of them and a negative 15 of them. So that makes negative 9 of them. My x's, it looks like there's just 1. And then I have my constants, 12 and 2, give me a grand total of 14. So there we are, subtracted, written in standard form. We are good to go. All right, last two examples. Graphing. Graphing polynomials by hand can be a real challenge. So we will be using our graphing calculator in this chapter. At times, if you're in a pinch, you could use Desmos. But as far as tests go and the SAT goes, you got to get pretty good with your TI-84 or 83, whatever you're using. So I'm going to demonstrate this. We're going to graph each polynomial. So what we need to do is we need to sketch, just a quick and dirty sketch. We need to describe the graph from left to right. So this is kind of the part that I'm really going to focus on, so we're kind of speaking the same language. And then we need to identify the number of real zeros. So 3 pieces: sketch, describe, tell how many real zeros there are. All right, well, let's look at this one on the left. I'm going to kind of get my little grid set up here. And let me pull up my trusty graphing calculator. Slide it over. And let's turn it on. And I'm going to go y equals, clear this out. Clear. I'm also going to check my window. I always want to make sure I'm in the standard. So whatever problem I was working on, I'm not in a standard window. So go to Zoom 6, and that'll put me in the 10 to 10 window. So now we're good to go. All right, so let's graph this equation over here. So I got to graph x to the third, take away x. So I got to do x, this little, underneath the clear button, this little caret, upside down v, x to the third power, arrow over to get back down. Be careful you don't use the negative key. Use the subtraction key, subtract x, and hit enter. And now I'm going to graph this thing. Well, I kind of have an idea of what's happening with the graph, but the zeros, I'm not really sure because it's just kind of cluttered right there. So what I'm going to try to do, I'm going to attempt to go in right here, and I want to zoom in on this area. So I want to kind of go from maybe x of negative 3 to positive 3. And then I want to go y's from like negative 2 to positive 2. I'm going to kind of zoom in on that. I could manually put those numbers in. I'm going to attempt to just hit the zoom and go 2. So I'm going to attempt to zoom in. And it's going to say, hey, where do you want to zoom into? My little cursor is flicking right at the origin, right at 0, 0. So that's a good area to zoom in on. So hit enter. And now I zoom in. Oh, and that's a lot clearer. So now I can have a nice little quick and dirty sketch of this graph. We basically, here's my grid. Looks like we're at 1, 2, 1, 2. I don't know, something like this. And here's what we got going on. We're coming up, we cross, come down, back up, and that's good enough. You don't really have to get into the nitty-gritty on where are those humps at or anything like that. Just, that's close enough. Now, the describe part, so here's what I want to do. When I'm thinking from left to right, I want to say whether the function is increasing or decreasing. So from left to right, it looks like I'm going up. I'm increasing, increasing, increasing. So we start off increasing. So that was that piece. All right. So right here, we're increasing, increasing, increasing. Well, then we start to decrease. Then we start to fall. So then we decrease. And then at some point, we take off and we start to come up and increase again. So from left to right, we're increasing, then decreasing, then increasing. So we've sketched it, we've described it, and now we need to put the number of real zeros. Well, how many times is y equals 0? It looks like 3 times. So we have 3 real zeros. All right? So that's all we really need to do for today. We're going to get more in depth later, but that's good enough. So let's clear that out, and let's move the graph over, and let's look at this other one. So I'm going to go back to y equals. I'm going to clear that out, and I'm going to go x caret 4, x to the 4th power. I got to hit the arrow over key to jump down, minus 8x squared. I guess I could have hit the squared button, but and plus 1. Now, remember, I'm in a weird window. Right now, I'm in the window from the last problem. So I could just gamble and just hit graph and maybe get lucky. Let's just graph. So that to me looks kind of like a parabola. But that might not be the whole picture. So maybe I'm going to zoom out a little bit. Because I'm pretty zoomed in pretty close. I'm going to go down to number 3 and I'm going to zoom out. I'm just going to say, hey, do you just want to use the center? Sure. Enter. Ooh, now I'm like, wait a minute, there's more stuff going on here. So honestly, I could zoom out again, but it might be too far out. I'm really interested on a couple things. Number one, I'd like my y's to go a little bit lower. So for instance, my x's, I can kind of see everything. I'm going to make my y's go a little bit lower. So in my window, tap window, I'm going to make my y max, or my y min, drop to negative 20. I want to go a little lower. Now let's see what happens. So I get this W looking thing. Now, as far as zeros go, it's a little tough for me to see right now. I definitely see I have a 0 here, a 0 here. It looks like I have 2 more. So I'm thinking I have 4. But just to get those zeros on the inside, I might want to zoom in on that area just to kind of see what's going on. So I'm going to just zoom in once or twice. Zoom in, enter, enter. Well, and then I got to go up a little bit. So that probably wasn't the best zoom in that I should have done. I'm going to try this. I'm going to try to zoom in, but I don't want to be in the center. I'm going to go up some. And I want to zoom in way up here. Enter. Oh man, still didn't show me much. So I'm going to manually do this. I'm going to go to my window and I'm going to go from x at, let's say, -2 to 2. Maybe I'll go by 0.5s. I don't know. I could even go by 1s. Why not? And then let's go -2 to 2 by 1s. Let's just see what that looks like. Oh yeah, so I can clearly see that we cut through there in the middle. And I kind of could see that a little bit in the very beginning. So maybe I'm going to just sketch this thing out. I'm going to say, all right, we came down, we went up, we came down, and we went up. Good enough for a quick and dirty sketch. So what are we doing? Well, we started off by decreasing. Then we increased. Then we decreased. and then we increased. So that's what the graph did. Decreasing, increasing, decreasing, increasing. And we have 1, 2, 3, 4 real zeros. All right. Hopefully that's enough to help you out and get you going on the homework. If you have any questions, feel free to reach out. Talk to me in class. See you.